Hey everyone, this video is on linear functions and applications. A function is a special kind of relation. A relation is a set of ordered pairs. This set may be finite or infinite. So anything that has ordered pairs is a relation. And we're going to talk about functions, which is a specific kind of relation. All right, here's an example. We have two sets, A and B, and they're both relations. They're also both finite because there's only 3 ordered pairs in set A and 4 ordered pairs in set B. So those were both finite. Here's an example graphically. So the first example we put here, there were just coordinates, 3 coordinates for set A, 4 coordinates for set B. Now we have an example where they're both graphs. So these are both graphs in 2 variables. They're also called relations. Since each point of the graph represents an ordered pair. If you look at the graph on the left, it's a line. It's called a linear function. We'll get to that in a little bit. But it's a linear function because it's a line. Line is linear. That line has an infinite amount of points to make that line. There's infinitely many points. The graph on the right, it's called a parabola. It kind of opens sideways. That also has infinitely many points. Right? So those points make up the graph, and they're called relations. Okay, so those equations on the previous slide specify how x and y are related. They both had equations. The first one was y equals x plus 1, and the second one was x equals y squared. So those are how x and y are related. Since the equations generate a graph, then the equations themselves are relations. Most of the relations that we study will be described with an equation. Okay, so here's some vocabulary. The first one is domain. The domain of a relation is the set of all x coordinates in the relation. So the x values are the domain. The range of a relation is the set of all y coordinates in a relation. So the range is the y. So this is important to remember. The domain is x and the range is y. Okay, so we'll look at some finite relations here. Example 1. Determine the domain and range of A. So the domain, we'll start with the domain. The domain is the x values. What are the x values? Well, the x values are 0, 1, and 2. Remember that x is first, then y is second. So that's the domain. What about the range? Well, the range is the y values. What are the y values? Right, 2, 3, and 4. Okay, let's do example 2. Same thing, determine the domain and range of B. So the domain is the x values and the range is the y values. All right, so the domain is -2. We don't have to list -2 twice because it appears twice. Just list it once. So -2, -1, and 0. And the range is 2, 1, 0, and -1. You could put it in order. I didn't put it in order for the range. I probably should have. It's not wrong. It was not listed in order. It just doesn't look good. So the domain I wrote in order from least to greatest, but the range I didn't. It just looks bad. Now I have to live with that. Okay, now we're going to talk about functions. A function is a relation that has a condition. And so here's that condition. A function is a relation in which no two ordered pairs have the same x-coordinate. So no ordered pairs can have the same x value. They can have the same y value. It's still a function, but they cannot have the same x value. Okay, so here's the two relations that we were looking at earlier. We have two sets, A and B. Here's the question, is A a function? So remember that what we said was they cannot have the same x value. No two ordered pairs can have the same x coordinate. So let's look at A. What are the x coordinates? 0, 1, and 2. Do either one of those coordinates have the same x value? No. Therefore, A is a function. How about B? Look at the x values. Do either of those coordinates have the same x coordinate? Yes, the first two coordinates, -2, 2 and -2, 1. Therefore, B is not a function. So A is a function since all x coordinates are different. B is not a function since the two ordered pairs, -2, 2 and -2, 1, have the same x coordinate. Okay, now we're going to look at the graphs. We looked at these same graphs earlier. So consider the two relations. Remember, any graph is a relation. Are they functions? So the issue is, for a relation to be a function, they cannot have the same x coordinate. 2 points on the graph cannot have the same x coordinate. So we're going to look at the graph, and then in the next slide we're going to talk about a little easier method to determine if it's a function or not. All right, let's look at the first one on the left. It is a function, since for any value of x, there will be exactly one value of y. So think about the equation y equals x plus 1. If you plug in 3 for x, what do you get? So it's y equals x plus 1. Plug in 3, 3 plus 1 is 4. There's no way to get a different y value. So it is not possible for there to be another ordered pair in this relation that has an x coordinate of 3. So an x value of 3 will only give you 4, no other number. Now let's look at the one on the right. This one is not a function. Because if x is 1, y could be 1 or -1. So if you plug in a y value of 1, you'll get 1 for x. And if you plug in y equals -1, well, -1 squared is also 1, because when you square a negative, it becomes positive. So there's two ordered pairs right there that show that this is not a function. There's another two ordered pairs, 4, 2, and 4, negative 2. If you plug in 2 for y, you'll get 4, as well as negative 2. So here are two ordered pairs with the same x-coordinate, and that is a direct violation of our definition for a function. Maybe I should have wrote that different. Violation seems like a strong word. But that's it. We can't have the same x value that has two different y values. That last slide was a little complicated. So instead of having to find these particular ordered pairs, there's an easier way to see if the graph represents a function. It's called the vertical line test. Okay, the vertical line test. To determine if a graph represents a function, we consider all vertical lines that intersect the graph. If any vertical line can touch the graph at more than one point, then the graph does not represent a function. If no vertical lines are able to touch the graph at more than one point, then the graph does represent a function. Okay, so a vertical line can only touch it at one point. If it touches it at more than one point, it's not a function. So here's our two relations that we've been discussing graphically. They're both infinite. The one on the left is y equals x plus 1. It's a line. So if you draw a vertical line anywhere on the graph, it will only intersect once. Here's a random vertical line, and you can see that it only touches once. If it only touches once, then it is a function. The one on the right, if you draw a vertical line through it, you could see that it touches twice. Therefore, that one is not a function. So the one on the left is a function because the vertical line will only intersect it once. It is called a linear function. And the one on the right is not because a vertical line can intersect it more than once. Okay, let's talk about function vocabulary and special notation. So we talked about the linear function y equals x plus 1. And if you replace x with another number, we could quickly determine what y is. If x is 3, y is 4, right? 3 plus 1 is 4. If x is 5, what would y be? 5 plus 1 is 6. So for this reason, we say that y depends on x. Another way of saying this is y is a function of x. So from this perspective, we can view x as the input to our function, and y then as the value of the function. So for y equals x plus 1, if x is 5, the value of this function is 6. The notation we will use to represent a function is f of x. That's how we say it or read it, f of x. You can see how it's written, an f in front of the parentheses with x inside the parentheses, it does not mean times. It looks like times. It looks like f times x, right? But it's not. It's a notation that we use for y. So instead of writing y equals x plus 1, we write f of x equals x plus 1. It means the same thing as y, but we're going to have to get used to this notation if you haven't already done so. So for functions, we will usually use f or g or h. That's just common. It doesn't mean we can't use another letter, but those are most common. The letter x in f of x is simply the letter we have chosen to represent a value in the domain of function f. So we could use any letter. We use x a lot. It's just kind of traditional. So altogether, f of x represents the y coordinate in an ordered pair for any given value of x. So remember, y is the same as f of x. All right, a couple of examples. Example 6. If f of x equals 2x minus 1, again, that's how you say it, f of x, f of x. If f of x equals 2x minus 1, find the value of f of x when x equals 4. So what that means is substitute 4 for x. Everywhere you see an x, replace it with the number 4. So on the left, we're going to write f. Again, we replace x with 4. So now that's saying f of 4. That's how you would read that on the left. F of 4 equals, and again, we're replacing x with 4, so 2 times 4 minus 1. Now we work it out on the right. 2 times 4 is 8. And then 8 minus 1 is 7. That's it. We don't divide by 4 on both sides, so on the left, it remains f of 4. It's saying that we have a function, and we're replacing x with 4, and the result is 7. That's it. So a lot of times people make the mistake by trying to keep going and dividing by 4. Do not do that. That would be wrong. Okay, this one, number 7, is a kind of a more condensed way of writing the problem. F of x equals 2/3 x minus 5. Find f of 12. So what that is saying is to replace x with 12. Okay, so 2/3 times 12 minus 5. You can put a 1 under the 12 and then do some reducing. You can use your calculator. So 3 goes into 12 4 times, and then 2 times 4 is 8. Or you can multiply 2 times 12 first, that's 24, and then divide it by 3, which is 8. Either one. Then you could subtract 8 minus 5, which is 3. So that's our final answer. F of 12 equals 3. Okay, now graphing. Some of you might have some graphing experience, some of you may not, so we'll try to go through that. A linear function is a function that can be written in the form f of x equals ax plus b, where a and b are real numbers. So we might have talked about the form y equals mx plus b, where m is the slope. Same thing here. We're just using a. If you want to write f of x equals mx plus b, that's also fine. Again, when they're talking about linear functions, a lot of times the textbook will write this f of x equals ax plus b. They're just numbers. You could use any letter you want. Okay, so f of x, again, we could use g of x, h of x. F of x is just common. It's the same as y. So when we say f of x equals ax plus b, it's the same as y equals ax plus b. The equation of a straight line with the slope of a, and the y-intercept is b. Now to graph, you have different methods. You could pick values for x, that's one method. You could also use the slope and the y-intercept if you're familiar with using the slope and the y-intercept. Okay, here's our first problem. F of x equals 2x minus 3. And we're going to do this by choosing values for x. So we're going to talk about what numbers to choose. I also think you should learn how to use a good calculator. If you're able to use a calculator in your class, I have a video on using a Casio, the 991. But there's whatever calculator you have, there's lots of videos on how to use them. Some of them are graphing calculators. Some calculators will give you the points on the graph and may not show you the graph, but they might just show you the points on the graph. All right. So we need some points to graph a line. We want 3 values usually. You could have only 2 values. If you have 2 coordinates for a line, that's enough points to make the line. Why do we want 3? Because then if they all line up, then you could feel confident with your work that everything's correct. If you choose two coordinates and you graph it and one of them's wrong, you will not know it's wrong. But if you have 3 coordinates and they don't line up, then you know you've made a mistake. So that's why we usually want 3 values. All right, so we're going to choose different values for x. Doesn't matter what points you choose for x or what values you choose for x, we still should get the same line. Okay, so what number should we choose? Well, it's f of x equals 2x minus 3. If I say y equals 2x minus 3, it's the same thing. Okay, so let's choose 0, 1, and 2. You can pick any numbers you want. You could pick x equals 57. But if you choose x equals 57, then you can see the graph I have here. I only went up to 6. So I'm going to have to make a really big graph. How about we not choose 57? How about numbers like 0, 1, and 2? If you want to pick some other numbers, -1, -2, that's fine. Now start plugging them in. Now here's where you could use a calculator if you want. Again, I have a video on using the Casio. This is not a hard problem to plug it in, but later on in math, there's going to be some other functions that are quite complicated. So it's nice to learn how to use the graphing feature, or actually I should say the table feature. So you're going to look for a table on the Casio. All right, so let's choose 0 first. So that means everywhere you see an x, plug in 0. So 2 times 0 is 0, and 0 minus 3 is -3. So across from 0, you should have a -3. Now plug in 1. So 2 times 1 is 2, and then 2 minus 3, -1. Let's see, one more value to choose. We're going to choose x equals 2. So plug in a 2 everywhere you see the x. 2 times 2 is 4. 4 minus 3 is 1. So now we're going to plot those three coordinates. We always start from the origin. The first coordinate is 0, negative 3. So you go to 0 from the origin, which means you don't go anywhere left or right, and then you go down 3. Do the same thing with the other points. So the second one is go over 1, so 1 to the right, and then down 1. And the third point is over 2 and up 1. Remember to always pause the video while you're working it out. Okay, and then try to draw a straight line. Maybe use like a index card or some kind of card so you could draw a straight line if you don't have a ruler handy. It is nice to use graph paper. You could always go to Google or something like that to just print up some graph paper if you want. Makes it easier. And that's it. That's a linear function. F of x equals 2x minus 3. So the last graph, we graphed it by choosing values for x. And that's totally fine. This time I want to show graphing it using the slope and the y-intercept. Okay, remember the slope. The slope is a number in front of x. So the slope is 2/5. And the y-intercept is -1. Previously we were talking about f of x equals ax plus b. A is the slope and b is the y-intercept. So in this case the y-intercept is -1. So you go to the y-axis, find -1, and plot your point. It's in blue. I don't know if you could see it. Now the slope, we're going to use that to find two other points. The slope is 2/5. You might recall the phrase rise over run. So that means they're both positive. So you're going to go up 2 and then right 5 from the y-intercept. Now you could also change that to -2 over -5, which means down 2, left 5. But we'll first start with up 2, right 5. So you go up 2, right 5, put a point. Up 2, right 5, put another point. So we have points at 5, 1 and 10, 3. Now, if you're not familiar with this method, you could also do what we were doing on the last example. Make a table and then choose values for x. If you choose values for x, we always start with 0. And then if you have a fraction, choose that denominator. So choose 5 for x. And then double that number and choose 10. So if you make a table, 0, 5, and 10 will be in the x column. Then do what we were doing in the last section and you'll get the same points. Okay, so here we're just talking about a different method. Okay, we were talking about if you have two positives, that's the same as two negatives. So you could also go down 2, left 5. Down 2, left 5. And then you could do it again. I don't think I have enough room on my graph for another down 2, left 5. Well, I do. It'll just be right on the outside edge. That's good enough. That's 4 points. So draw your line And we're all done. So the slope was 2/5. So they're both positive. That means keep the phrase in mind. Rise over run. Up to right 5. Up to right 5. If you had a negative, then you would choose a negative to be with either one of those numbers, usually the top number. Then it would be down to right 5, down to right 5. But this one was both positives. So up and then right. Here's another function. If it's in the form f of x equals b, and b is a real number, then we call it a constant function. And the graph of a constant function is a horizontal line. So in this case, there is no slope. There's no a, right? There's no x. So if there's no slope, that makes it a horizontal line. It cannot be a vertical line because a vertical line is not a function, right? If the graph is a vertical line, if you draw a vertical line and try to do the vertical line test, it hits everywhere. So keep that in mind. A vertical line is not a function. So f of x equals 5. No matter what the x value is, it's always 5. The y value is always 5. Although the domain of the function consists of all real numbers, the range is comprised of only one number, 5. So all you do is go to 5 on the y-axis and then draw a horizontal line through that point. That's it. Nothing else to do. Here's another example. F of x equals -2. Again, find -2 on the y-axis and draw a horizontal line. That's it. It's all done. Okay, on the last lesson, we were talking about equations of lines. And we used the formula y equals mx plus b. Well, y equals mx plus b is the same thing as f of x equals ax plus b. So we're going to do the same thing again. The only difference is instead of f of x, instead of y, we write f of x for our answer. But it's the same thing that we did in the last video. The last video was called Equations of Lines. All right, so let's do what we did last lesson. Y equals mx plus b. The first value is x, the second value is y. So we're going to substitute those values. Y is 9, m is 2/5, x is 4. We're going to simplify and then solve for b. So 9 equals 2/5 times 4 plus b. You can put a 1 underneath the 4, multiply straight across. So 2 times 4 is 8. And then it's up to you here. You could either multiply by 5 everywhere to clear fractions, or you could subtract 8/5 on both sides. It's totally up to you. I'm going to clear fractions, so I'm going to multiply everything by 5. On the right side, the 5's cancel. So now we have 45 equals 8 plus 5b. Don't forget to multiply the 5 by b. Now this isn't necessary if you subtracted 8/5 on both sides. If you subtract 8/5, you could either use a calculator, or you could get common denominators. All right, subtract 8 on both sides, and then divide by 5. So b equals 37 over 5. Okay, so now to write our answer, we have m is 2/5. So replace m with 2/5. Replace b with 37 over 5. And instead of using y, we're going to use f of x. So there's our answer. F of x equals 2/5 x plus 37/5. So if you need more practice on this, again, we did a video on equations of lines, and there's plenty more examples. Okay, here's another example. We want to determine the linear function that contains the indicated pair of points, 3, 10, and 7, 2. So we have 2 points, but what we do not have is the slope. How do we find the slope if we have 2 points? Right, we use the slope formula. M equals y2 minus y1 over x2 minus x1. So label your points x1, y1, and x2, y2, and then substitute the values into the formula. All right, so it's 2 minus 10 on top and 7 minus 3 on the bottom. That's negative 8 on top and 4 in the bottom, which is negative 2. So we have our slope. Now you could use either point. We got to find b. You could either use a 3, 10 or the 7, 2. It really doesn't matter. It's totally up to you. And we're going to use y equals mx plus b to find b. So I'm going to use 3, 10, but you could use 7, 2. It doesn't matter. Isn't that amazing? We'll get the same value for b. All right. So y is 10, m is negative 2, and x is 3. Negative 2 times 3 is negative 6. Here we could just add 6 to both sides. So b is 16. So now we have our m and our b. So we could write our final answer, f of x. Remember, don't use y because they said function, so we want to use f of x. F of x equals negative 2x plus 16. Okay, determine the linear function with the following conditions. We have the point negative 1, 4, and it's parallel to the line g of x equals 3x minus 2. Okay, so a couple of things. It says g of x. Why? No reason. It could say f of x. Just a letter we use for functions, g of x. Parallel. What does that word mean to you, parallel? Well, it should mean that they have the same slope. So remember the words parallel and perpendicular. Parallel means same slope. Perpendicular means opposite reciprocal. So the next example we'll do perpendicular, but this one is parallel. So we just need to compare it to this line, g of x equals 3x minus 2. What is the slope of g of x? Well, the slope is the number that's in front of x. So therefore, the slope is 3. So I just wrote that in words. Since the lines are parallel, the slopes will be the same. The line is already given in slope-intercept form. It will always be given in slope-intercept form because it's in function form. So we just need to know the number in front of x to determine the slope. That means it's 3. All right, so we know that m is 3 and the point is -1, 4. So now we just use our y equals mx plus b. All right, so 4 is y, 3 is m, and x is -1. 3 times -1 is -3. Add 3 to both sides. So b is 7. So we have our m and our b. You could use whatever letter you want for a function. I like to use f of x. So f of x equals 3x plus 7. All right, example 14. Very similar to the last problem, only this one says perpendicular. What does perpendicular mean? It means opposite reciprocal. The slopes are opposite reciprocal because they intersect at a 90-degree angle. So we're going to compare it to this line h of x. Again, a different function, different letter. What is the slope of that function? Right, it's 2/5. But since this is perpendicular, we're going to flip it and change the signs. So that's what that says. Since the lines are perpendicular, the slopes will be opposite reciprocals of each other. Rewrite the line given in slope-intercept form to determine the slope. Well, it's already in slope-intercept form. I don't know why I wrote that. So 2/5. The slope is 2/5, but we're not going to use 2/5, right? We're going to use -5/2. All right, hopefully you're doing okay. So we just look at the number that's in front of the x. That's our slope, 2/5. If it said parallel, we would not change it. We would leave it as 2/5. But since it says parallel, we flip it. That makes it 5/2. And then we change the sign. So since it's positive, we change it to a negative. If it were negative, we would change it to a positive. Okay, so now we got the slope that we're going to use, -5/2. So we're all done with h of x now. All we needed was that number, -5/2. And now we're going to use the point, -3, 8. And we're going to use y equals mx plus b. So 8 is your y. M is -5/2. X is -3. So now solve that equation. Remember to always pause the video, work it out, and then come back when you're ready. Okay, put a 1 underneath the -3. Multiply across. That's 15/2 positive. You could either subtract 15/2 on both sides, or you could clear fractions by multiplying everything by 2. I chose to multiply everything by 2. There in the middle, the 2's will cancel. So we get rid of fractions. So now you have 16 equals 15 plus 2b. Now subtract 15 on both sides and then divide by 2. So 16 minus 15 is 1, and now divide by 2. So B is equal to 1/2. We've done all the work. Now we just got to replace the M with -5/2 and the B with 1/2. And instead of Y, use f of x or g of x, whatever you want to use. So f of x equals -5/2 x plus 1/2. All right, here we are, our last example. Rent-A-Wreck car rental charges $25 per day plus 21 cents per mile to rent a car. So if you rent this car, maybe you're at a racetrack and they're going to charge you for the day $25, and then each mile you drive 21 cents. Okay, so it could be something, I don't know what it is, but anyways, that's the idea. So if they're going to charge you $25 for the day right off the bat. And then if you only drive 1 mile, let's say you drive 1 mile, they say, okay, I'm done. So your bill is going to be $25.21. If you drive 2 miles, well, 2 miles would be 42 cents. So your bill is going to be $25.42. So if you keep putting on miles, they're going to charge you more. Yeah, I can see how this could be a real problem. Like if you're renting at some kind of racetrack, and they're going to charge you a $25 fee, and then however long you want to drive, however many miles, they're going to charge you by the mile. Okay, so here's our first part. Determine a linear function that can be used to calculate daily car rental. So we're just talking about the day. So we want to make an equation. So we're going to use f of x because it's a function. You could use anything you want. You could use r of x for rentals, or c of x for cost. So if you want to use c of x, you can. All right, so what would that function be? Again, they're going to charge you $25 plus, and then 0.21 times the number of miles. So that would be our x. So x is the number of miles driven per day. So hopefully you got the equation. This would be our equation. F of x equals 25 plus 0.21x. So if you drove 1 mile, you would replace x with 1, and it would be 25 plus 21 cents, $25.21. 2 miles, 0.21 times 2 would be 42 cents. So $25 plus 42 cents would be $25.42. Okay, now part B, we're going to use that function and determine the cost of renting the car, and we drove for 300 miles. Gosh, that seems like a long day. Yeah, 300 miles seems like a couple hours, maybe 3 hours, 4 hours. All right, so that means we're going to replace x with 300. So we're going to find f of 300. So it's going to be 25 plus 0.21 times 300. So use your handy dandy calculator and multiply 0.21 times 300, and you should get 63. So now you add 25 and 63, 88. So your bill should be $88. All right, that was our last problem. Hope it wasn't too bad. I'll see you here for the next video. Have a good day.